Thevenin's theorem and Thevenin's and Norton's equivalents are one and the same, right? So if you look at this diagram, in this diagram there are two circuits. The first circuit is Thevenin's equivalent circuit, and the second circuit is a Norton's equivalent circuit. So generally, so every complex circuit can be represented into a voltage source in series with a resistance is called as a Thevenin's equivalent. And a complex circuit, if you are able to represent it into a single current source in parallel with a resistance, then it is called as Norton's equivalent. So now these two theorems are much useful in calculating the theorems. So how we can get this one is, let us first see the statement of this Thevenin's theorem. Thevenin's theorem states that it is possible to simplify any linear circuit, no matter how complex, to an equivalent circuit with just a single voltage source and a series resistance connected to a load. So Thevenin's form is a series combination of Thevenin's equivalent voltage source V0 or VTH. We call it as either V0 or VTH. It is called as, and Thevenin's equivalent resistance R is RTH and kuda anantam. Then coming to the Norton's theorem. So what is Norton's theorem states here? It is, so it is possible to simplify any linear circuit, no matter how complex, to an equivalent circuit with a just single current source and a parallel resistance connected to it. So in that, so a parallel combination of Norton's equivalent I0 or IN also we can, and Norton's equivalent resistance R is RTH and kuda antaru rendu kuda okate. So Thevenin's theorem, a resistive circuit can be represented by a one voltage source or one resistance like. So you look at that. This is a resistive network, right? This is a simple resistive network, and where you have voltage source and you have 1, 2, 3, 3 and 4 resistances. And this resistor, this circuit between these terminals A and B can be represented into a Thevenin's equivalent across the same two terminals A and B. అంటే ఈ రెండు terminals A and B మధ్యన దానికి ఈక్వలెంట్ గా ఇలాగ రిప్రజెంట్ చేస్తాం. అంటే ఒక voltage source in series with a resistance, and this voltage source magnitude is nothing but the VTH అని అంటారు, or VOC అని అంటారు. So where VTH, Thevenin's voltage, is equal to VOC, which is equal to VAB. అంటే ఎక్కడ voltage అంటే ఇక్కడ అన్నమాట. VOC అంటే ఇక్కడ voltage. This is the VOC, open circuit voltage, right? And Thevenin's resistance, that I will tell you how to find out the RTH, right? So with simple example, we can find out the Thevenin's equivalent of this circuit. Let us consider this circuit of figure 6, where you have two sources. One is 25 volts voltage source, another one is 3 amperes current source. Now we want to represent a Thevenin's equivalent between the terminals A and B. So let us find out how do we solve this. So in order to find the Thevenin's equivalent circuit for this circuit shown in figure, calculate first the open circuit voltage VAB. First we have to calculate VAB. So then VOC and kuda antam. So note that A and B terminals are open circuited. Therefore there is no current in 4 amperes. So here current there is 0 amperes current. Therefore what is VOC here? VOC is same as, when there is no current, VOC or VAB is same as V1, which is equal to the voltage across this current source. That is 3 amperes current source. So to find this V1, solve the equations for the singular node. So now here this is a singular node. Then apply the nodal equations here. So what is the nodal equation? We'll get the nodal equation for that one is V1 minus 25 by 5. Ante a current is indalo current. This current V1. This is V1. So V1 minus 25 by 5 will be the current in this branch, plus V1 by 20. So what is V1 by 20? Ante this current is V1 by 20. Then inko current is equal to 3 amperes. Or minus 3 amperes is equal to 0. So this is the nodal equation of that. So in this nodal equation, only one variable we have, V1 is the one variable, and if you solve this equation, you will get the V1 as 32 volts, and this V1 we call as the Thevenin's voltage VTH, since VTH is equal to VOC is equal to V1 is equal to 32 volts in this one. So this is how you calculate the first step, the Thevenin's voltage across the two terminals VAB. VAB and kuda antam. Ante idi ekkadante idi. This is the voltage. Right. So then next step is to find the RTH. So మన Thevenin's equivalent కట్టాలంటే VTH రావాలి, తర్వాత RTH కూడా రావాలి. So RTH find out చేయడానికి there are two methods. This is method 1. So method 1 లో ఏం చేస్తామంటే, we have to find out the equivalent resistance across these two terminals కాబట్టి. So what we do here, it is you short circuit these terminals, and these short circuited terminals లో పోయే current let us designate it as ISC, and then find ISC. Right. Already VOC you have calculated. So then your RTH is equal to VOC or VAB divided by ISC. This is the RTH will calculate. Now let us first find out ISC. ISC ఎలా calculate చేస్తాం? Once again use the nodal analysis. So దానికి nodal analysis వేస్తే ఇక్కడ voltage ఈ nodal analysis వేస్తే what we will get, we have assumed it as this is the voltage across this terminal, V2 is the voltage, and the same voltage here also appears. So దీనికి nodal analysis వేస్తే V2 minus 25 అంటే ఈ current, V2 minus 25 అంటే this current, V2 minus 25 by 5 is the current in this one. Then V2 by 20, next current is this, V2 by 20. See here, V2 by 20. Then 3 amperes current is entering about minus 3 amperes. This is minus 3 amperes. Then you have one more current here, this current V2 by 4, right? So is equal to 0. So we will get from this one we will get a V2 as 16 volts. So if you solve this one, you will get a V2 as 16 volts. Once you get the V2, you want ISC. ISC is the ISC is the current in this 4 ohms branch. So how do you find out the current in the 4 ohm branch? Current in the 4 ohm branch is equal to VT by 4. So that we have substituted. V2 is 16 volts. 16 by 4 will give you 4 amperes. Once you get the ISC, as I mentioned earlier, so ISC RTH is equal to RTH is equal to VAB or VOC or VTH. Anni same. ఇవంతా కూడా సేమ్ by ISC. అదే ఫార్ములా ఇక్కడ యూస్ చేసాను చూడండి. RTH is equal to VTH by ISC. Where VTH already we have calculated as, see here, VTH we have calculated and it is given as 32 volts, right? Therefore, VTH you substitute as 32 volts and ISC we got as 4 amperes. Therefore, 32 by 4 will give you 8 ohms. This is how you will calculate the R Thevenins. And there is another method to find R Thevenins also, my dear students. This is the second method for finding the R Thevenins. You please carefully. And this method is only applicable for independent sources. This method is applicable only when circuit contain independent voltage sources. Independent sources, either voltage source or current sources. Dependent sources unte kanaka this method is not applicable. Only dependent sources unte kanaka this method you can apply, which we have quoted here. So this method can be applicable for both independent or dependent sources, whereas this method of finding the R equivalent is only applicable to independent sources. The circuit contains independent sources. ఇప్పుడు మనకి తీసుకున్న ఎగ్జాంపుల్ మనకి ఇండిపెండెంట్ సోర్సెస్ అని 25 volts వోల్టేజ్ సోర్స్, ఇంకోటి 3 amperes, రెండు కూడా ఇండిపెండెంట్ సోర్సెస్ కాబట్టి now let us find out the RTH of this one. RTH దీన్ని RAB అంటారు. ఆల్రెడీ మనం ఈక్వలెంట్ రెసిస్టెన్స్ అక్రాస్ ద టూ టెర్మినల్స్ ఎలా కట్టాలి అనేది మనం చూసాం. సో హౌ డు యు ఫైండ్ ఈక్వలెంట్ రెసిస్టెన్స్ ఆఫ్ ఎనీ సర్క్యూట్ బిట్వీన్ ద టూ టెర్మినల్స్? సో ఆ ఈక్వలెంట్ రెసిస్టెన్స్ కట్టేటప్పుడు వాట్ వి డు హియర్ ఇస్ ఇఫ్ దేర్ ఇస్ ఎన్ వోల్టేజ్ సోర్స్, యు రీప్లేస్ దిస్ వోల్టేజ్ సోర్స్ విత్ షార్ట్ సర్క్యూట్ like this. See here. So we have replaced that voltage source with a short circuit like this, and replace the current source with a open circuit here like this. So the independent sources, if you have voltage source and the voltage source is replaced with a short circuit, and if you have a current source in any point in any branch and your current source will be replaced with a open circuit, then you find out RAB and which is same as RTH. So now how do you find out RAB or RTH for this circuit? If you look at that, these 5 ohms and 20 ohms are connected in parallel. See here, that is why these 5 ohms and 20 ohms are parallel, and the combination is in series with 4 ohms. So 5 ohms of you have to parallel combination అంటే ఏం చేస్తాం? Product 5 into 20 by 5 plus 25 plus 4. Then what will get 5 into 20 is 100. 100 by 25 is equal to 4. 4 plus 4 you will get as 8 ohms, which is given by this answer. So your RTH you will get as 8 ohms, which is the same as that of the RTH we got in the method 1. So either you can use the method 1 or method 2. Generally, method 1 is applicable to all types of circuits, irrespective of the way it is a dependent or independent source. Now let us, this is the total equivalent, Thevenin's equivalent circuit, right? This is VTH and this is RTH. So RTH you got as 8 ohms and VTH you got as between the terminals A and B. So that circuit, the equivalent circuit across the A and terminals can be represented with a Thevenin's equivalent circuit as like this, with a Thevenin's voltage of 32 volts and a Thevenin's resistance of 8 ohms. So this is about the Thevenin's equivalent circuit.